Hello, welcome to Chapter 6, Section 3, Example number 4, Solving Systems by Elimination. We're going to do an application problem. And one thing I need to stress with this, as many of you know, I also teach the Algebra 2 class. We do a lot of problems in that class, in the Algebra 2, like this one. As a matter of fact, the project for the first quarter is very similar. This is how we set them up for writing the steps for that problem. So please pay real close attention to what I'm going to explain here, because you're going to be seeing this quite often. So we know that Sam spent $24.75 and he bought a dozen flowers for his mom. Now he bought a combination of roses and daisies. Now I didn't do a screenshot of the picture. If you want to look in the book, there's a cute little picture of flowers. But we know that roses cost $2.50 each and daisies cost $1.75 each. So what we need to figure out is how many types of each flower did Sam buy for his mom. You guys should think about buying flowers for your mother while I'm talking about this. All right. So the first thing we need to do is we need to pick variables. Well, we have variables. I'm sorry. This is why people get confused about what a variable is when teachers misspeak like that. We already know we've got two variables. It says how many of each type of flower, roses and daisies. What we need to do is decide on letters that are going to represent this. So the first thing I'm going to do is I'm going to say let R represent the number of roses that Sam bought. And we're going to let D represent the number of daisies. Now, I cannot stress how important it is you do that step, because whenever we do a problem like this, which is an application problem, a word problem, a story problem, whatever you want to call it, whenever we do problems like this, almost every time someone says X equals this, Y equals that. And I was like, well, that doesn't answer the question. Well, I did all the work. Of course it answers the question. My final answer here has got to be Sam bought this many roses and this many daisies. Now I'm going to use R and D to represent that. I could have used X and Y. If I was going to graph these like in an earlier section, then I would use X and Y, because Desmos doesn't know what R and D is. Neither does this. And it also helps me out remembering R stands for roses, D stands for daisies. If you want to use X and Y, cool, no problem with that, okay? However, it does make a little bit more sense. And please remember, my final answer is going to be written in, this is how many roses and this is how many daisies that Sam is going to buy. What do I know about equation? What do I know to making some equations here? Well, I know he bought 12 total flowers, so that's easy. The number of roses plus the number of daisies equals 12. But now the next one is a little bit harder, and I'm going to talk you through it, okay? He paid $24.75 total. Each rose costs $2.50. So how much did he spend just on roses? Well, let me show you something with the calculator, right? And this is just for explaining. It's not you don't need a calculator for this part. It's just explaining stuff, okay? How much does he pay for one rose? That's going to be $2.50 times 1. I don't need a calculator for that. It's still going to be $2.50, and notice it went to one decimal place, but that's okay. How much did you pay for 2 roses? That's $2.50 times 2. And you could probably figure that out. That's $5. How much do you pay for 3 roses? $2.50 times 3 is going to be $7.50. And one more time, $2.50 times 4 is going to take $10 to pay for that. So what am I doing every time? I'm multiplying $2.50 times the number of flowers, the number of roses that I'm going to buy. How does that help? How many roses are you going to buy? You don't know yet. That's what we're figuring out. But I can show if I multiply 250 times the number of roses that he bought, which is R. That's why it's important that you do this. Sorry about the phone. That's why it's important that you do this, because R represents that number that I don't know. Now let's talk about daisies. Daisies are $1.75. 1.75 times 1 is $1.75. 1.75 times 2 is going to be $3.50. 1.75 times 3 daisies, it's going to be $5.25. What am I doing? I'm multiplying the cost of each rose by daisies, the cost of each daisy by how many daisies I'm going to buy. How many Sam. How many daisies does Sam buy? D stands for daisies. So it's $1.75 times the number of daisies. And if I take how much he spent on roses plus how much he spent on daisies, we find out that he spent $24.75 total. And usually that's the part that causes a lot of people stress. So rewind that, watch it again, ask questions in the discussion if you don't understand. Even my Algebra 2 kids, they asked about that when we were doing all the problems that we did in the first quarter. Awesome. Both of these are now in standard form, but I have a problem. Neither one of them are going to be nice so that if I add, I'm not going to get elimination. No problem. See that 250? Well, all I have to do is multiply the first equation by negative 250, and then I'm going to get my r's to drop out. So I'm going to multiply by negative 250. So I get, and actually put a little space here because I don't want you to get confused. Negative 250 times r is negative 250r. Negative 250 times d is negative 250d. And negative 250 times 12 is going to be negative 6. But you don't believe me, so I'm going to do negative 2.5 times 12. What did I say? Did I say 6? I'm sorry, I was thinking that I did the 0.5 and then I forgot to do the 2. Negative 30. So I get negative 30. And we're talking about money, so I'm going to leave it like that. The other one I'm going to leave alone. 2.5r plus 1.75d equals 2475. The r variables are going to get eliminated. Negative 250 plus positive 250 equals 0. Negative 250 plus 1.75 is going to be negative 0.75. So the difference in the price is actually 75 cents. But don't worry about that right now. And then negative 30 plus positive 24.75 is going to be negative 5.25. And if you don't believe me, we'll do negative 2.5 plus 1.75. That's negative 7.75. Negative 30 plus 24.75 is negative 5.25. I'm going to divide. Probably need to move that up so you can see it. Negative 0.75. And I'm going to take this, I'm going to divide it by negative 0.75. That tells me that the number of daisies was 7. Cool. Now, I know that the number of roses plus the number of daisies equals 12. So the number of roses plus 7 flowers equals 12. And if I add negative 7 to both sides, that tells me that he bought 5 roses. All right, so now we're going to check. Now the first part of the check, I'm running out of space here. The first part of the check is just, does 7 plus 5 equal 12? Or actually 5 plus 7, does that equal 12? Yes, it does, all right? That works. But now the other part of the check, I'm going to use this. 250 times 5 plus 175 times 7. Does that equal 2475? And I'm going back to the method of checking that I used in substitution, where I'm replacing the variables in both of the equations, right? It just made more sense with this one because that first one was easy, you could do in your head. So I got 2.5 times 5 plus 1.75 times 7. That equals 2475. So that is true. All right, now this is where people, yeah, I'm sure you've seen those NFL videos that I love where someone's running for a touchdown and they start celebrating too early. And they drop the ball before it crosses the plane to go into the end zone. All right? If you don't believe me, just Google or go to YouTube and look for celebrating too early. This is where, if we stop, we're celebrating too early. We didn't answer the question. We did math. We did a lot of math. We did 11 minutes worth of math. But we have not answered the question yet. The question is, how many of each type of flowers did Sam buy? So you need to write, Sam bought 5 roses and, right here, 7 daisies. That's all you had to do, just answer the question. See you in the next video.